Good afternoon. Patrick McGarry, work with Inc. We're the folks bringing CEPH to the world. I'm the director of community, so spend most of my time interacting with the developer community with a little set aside to evangelize and help people understand what CEPH can do. So today we'll talk about a little bit about CEPH. I'll start with a quick kind of my CEPH in 30 seconds or less. But then we'll dig a little bit deeper into some of those concepts and kind of how CEPH works for those of you that aren't necessarily as intimately acquainted with it. I apologize if some of this is a duplicate of what you heard. Unfortunately, my Dutch is somewhat less than non-existent, so I comprehended absolutely zero of what we did for listeners. But after we dig a little bit deeper into CEPH, we'll take a look at kind of some of the ways that CEPH and OpenStack are plugging together from the CEPH point of view. And then some of the project intersections. CEPH actually has quite a few project intersections, open source projects and other things that people are working on in ways that kind of CEPH is just becoming a pervasive solution for many different things. And then we'll look a little bit forward with what is kind of coming down the pipeline, what's in the future for CEPH and maybe some of its related friends. And then hopefully we'll have some time for questions. So here's the 30 seconds or less. Some good time. What is CEPH besides Wicked Awesome? CEPH is software. This is something that a lot of people miss out on. I'm sure that they probably covered this in the earlier presentations, but a lot of people say, okay, so when can you ship me my CEPH? Well, CEPH is the software, so it's software storage, software-defined storage. Excuse me. So it's basically our hope is to take the same approach that Linux did in the data center years ago and be able to provide cheap, affordable storage that has even more capabilities than you get with your large, monolithic, forklift-delivered solutions today. It's all in one. It does object, block, and file, all from a single cluster. And that actually gives you a lot of power in terms of reducing the amount of overhead. So that's another cost savings. So we kind of wanted to put a lot of thought behind different ways that we can kind of utilize the fact that it can be unified. And we can talk a little bit more about that later. Crush, I just wanted to highlight Crush. Crush is kind of the academic part of CEPH. Crush is the algorithm, the placement algorithm that allows CEPH to do what it does so well. Crush, it's kind of what allows CEPH to be aware of your infrastructure. You can actually tell CEPH about your data center, how things are laid out, create your own failure domains, and we can get into it a little bit more later again. But Crush is kind of the, you can see the picture's a little small there, but Chuck Norris is holding a bottle of awesome sauce. So that's kind of what that's all about. And then scale. CEPH is all about scale. It was designed for the exabyte and beyond. It's really designed to scale to the insane levels of data production that we see today. Everybody needs storage, and it's becoming even more apparent as days go by. So that's kind of CEPH in a nutshell, but we can dig a little bit deeper now into what else it has. I wanted to start with a little bit of a history of CEPH. I don't want to dig too much into this because Sage can spend, and does spend, an hour talking about the history and the beginnings of CEPH, because, well, we just launched InkTank this last year. It's actually been a project since about 2004. It started as a Department of Energy research grant out of the University of California, Santa Cruz, which is where Sage was doing his PhD and kind of where CEPH came from. The funny part of this is that he was working on a secure government facility. He had a radiation badge and a tag, and he had to sign in. But he would go into his cubicle every day, and he would write open source software, and he would check it into the repository over SSH at the university. So it was relatively funny from that. But from the early days, he had kind of this research project, and it was interesting and fun, and he learned a lot of things. And then he kind of, as he was finishing that up, he realized that as he came out of that, all of the people that he'd worked with in his project, all of the friends and coworkers and professors and everybody at the university, they had some really amazing, innovative ideas, and they would get done with their work at university, and they would go out into the real world. And he realized that as they were transitioning to the real world, that these large existing companies would snatch them up because they wanted the people and not the ideas of the project. So all of these projects kind of got just left in the lurch and disappeared, and a lot of them were really revolutionary. And Sage is kind of the wonderful idealist, and so he decided he didn't want any part of that, and he wanted to take his project and his ideas and all of the ideas that he gathered from his friends and his coworkers, and he wanted to bring it to the world and help change the industry. And so we can thank him for his idealism. And then the next stage is he had already founded a company called DreamHost, which is a web hosting company. And so he went back to DreamHost. It was kind of the reason that he went and started all of this in the first place. He wanted kind of to originally solve some selfish problems of his own, because obviously as a web hosting company they had huge data storage needs, and they were paying lots and lots and lots of money to these existing vendors, and he was less happy with that than he might otherwise be. And so he went back, and so between the fact that it was the Department of Energy, it was the project to build a better luster, right? So it was originally designed for these HPC workloads, but he kind of had these selfish needs as well, that when he got done with that, he wanted to take it to the real world and help solve some of his own storage problems. So that's a little bit what he did at the incubation period here. Taking Ceph from a research idea with HPC workloads in mind and bringing it to the real world, and that's kind of where it started to take shape as a platform that could provide multiple different types of storage and service a wide variety of workloads. And then in 2012, like I said, we launched InkTank because a number of commercial entities were approaching Sage and saying, we'd like to use Ceph, but we would like help getting there, or we would like to be able to support it because my company doesn't allow us to use anything unless we have a support contract. If aliens invade and they blow up our data center, we need someone to help recover and get it back. And then from there on, we're in this growth stage now, where we see an amazing explosion of interest in Ceph, and we're extremely excited. It's amazing the number of places where Ceph just seems to be cropping up. We have probably more than we can keep up with in terms of people that are approaching us and talking about, hey, I want to stand up Ceph, or I just stood it up and now I want to take it to production. But as exciting as that is, we find that there are even more people that are just using it. So there are more installations that I can count. I'm finding out probably tens of installations every week. It's extremely exciting. So that's kind of a little bit of the history of Ceph. Now, the mechanics of Ceph. How does Ceph work? What is it? Underneath the covers, if you're familiar with these things, Ceph is just a big object store. And this is kind of one of the first immediately apparent ways that you can tell that Ceph is a little bit different. A lot of these other competing storage products, even other open source projects, tend to take a bit of a different approach. They'll start with a block device or a file system underneath it all. Ceph kind of took a little bit of a departure and used an object store. We get some things for free for that, and it's quite interesting what you're able to do using an object store underneath. And I won't get too deep into the semantics. If you're highly technical and interested in those kinds of things, we can probably talk otherwise. But the nice thing with the object store is we provide a number of different ways to talk to it. And this is where we get the Ceph gateway. This is our RESTful gateway. This is the S3 and Swift. We talk both, and they're actually interchangeable now. If you want to have a big object store, you can talk to it with some things with Swift, you can put things in with Swift, and you can take them out with S3, and vice versa. So we kind of combine the semantics of the two. We started with our S3 integration, our S3 API, which means our Swift API is slightly different because we had to change a few things like global namespacing and whatnot. So, but the advantage here obviously is that it can talk either and it can talk both. So that's pretty cool. The other way is the Ceph block device, and this is where we're seeing most of the people that are coming inbound to us right now are coming via OpenStack. And they're coming to talk to us because they say, hey, I stood up an OpenStack cloud, and I see that Ceph talks or can provide me a block device for Cinder and Glance. And I'm really excited to find out more. Then they realize that there's all this other stuff that Ceph can do and can handle workloads for not only their OpenStack cloud, but maybe a bunch of the other things in the enterprise as well. And they can kind of streamline down. And I mean, anybody that runs a data center, I'm sure you know, The fewer things that you have to manage, the fewer balls in the air, the easier juggling game tends to be. And then the final one is CEPH, the file system. I've heard that mentioned a few times. I wasn't sure of the scope of that mentioning, but CEPH file system, well, the object and block devices are awesome. We like to refer to as CEPH as nearly awesome. Originally, the work, the research grant, and everything with CEPH started as CEPH. And so you can imagine, Sage has a high degree of desire to get back to the CEPH roots, but unfortunately, we have limited resources, and we had this avalanche of desire come in for object and block, and so that's kind of where we focused our efforts the first bit of our lifespan. But CEPH, well, we aren't saying it's commercially supportable or production ready. There are a number of people that do have it in production right now. Some of those folks are national labs types people using it in HPC-ish workloads. So if it fits a certain profile, you can still use CEPH. It's just, in the next coming months, we're hoping to make that a lot better. So what does this look like in practice? So if you want a CEPH cluster, you're going to have some number of disks in physical machines somewhere. On top of those disks, you're going to have a file system. We would love to see ButterFS be the future. Unfortunately, as many other people, we've been waiting for ButterFS to be the future for like the last 10 years. So who knows when we'll get there. Most of our production customers are using XFS. It has larger extended attributes and some other things that kind of give you a few inherent wins that are nice, despite the fact that we don't get some of the unique cloning and functionality of Butter. But you can also use X4 or ZFS and most of the other popular options. So on top of that file system, you have your OSD. That's your object storage daemon. It's just a software process that runs. And what you get when you put all this together is you have one OSD node. That's the storage node, that's the guts. Our OSDs are built with a certain amount of intelligence in them. So these OSDs are always chatty. They're always talking to each other, they're always peering, and they're always kind of figuring out what's going on in the cluster. So with that intelligence means that we have a certain amount of self-healing capability. If one of these OSDs explodes, all of the other ones will say, hey, he's down, I knew what data he had, and I can show you a little bit more about this in a minute. But your cluster, a basic cluster, is going to be made up of a bunch of these intelligent OSD nodes, and then some small number, usually 3, 5, I think the largest cluster that I've seen so far has used 7 because they wanted a lot more redundancy, but a small number of these monitor nodes. Now, one of the interesting things about the monitor nodes is, well, they are important for things like authentication, and they use a Paxos algorithm to decide for decision making within the cluster, so that if someone says, hey, OSD 47, he's down, and a whole bunch of people say that, and a whole bunch of people say he isn't, the monitors are the ones that are going to decide, yeah, okay, we're going to mark OSD 47 as down, get it out of the cluster, we're going to rebalance the data so that everyone can agree on the fact of what data is available and from whom. So they're the ones that are kind of herding the cats inside the data, inside the cluster. So I mentioned Crush. Crush is our pseudo-random placement algorithm. This is kind of what decides where the data goes, how it gets there, and this is a key differentiator for Ceph. A lot of people may be familiar with, like, my good example is Hadoop. If you have Hadoop, you have a single name node architecture. It's widely known as kind of one of the early bottlenecks when you're trying to work with Hadoop. I put something in a cluster and then I wrote down where I put it. And so every time you want to go get something, you have to go look, okay, where is it? And then I go get it. With Ceph, instead of going and looking at where you wrote that down, it uses an algorithm to say, based on the state of my cluster, and where I've decided things are going to live, I will calculate where it's supposed to be, and it will always be in the right place. So that calculation is repeatable. So this means that you can have the ability for clients to say, and where is this supposed to live within the cluster, and it will go directly to the OSD on where that data is stored for both putting it in and taking it out. Even if the cluster is changed, now based on the state of that cluster, you'll know exactly where to find it. So Crush is really, really cool. It's my favorite part about Ceph. And the nice thing about Crush is that it also comes with a Crush map. So that means I can say I have, n racks in X rows in Y power domains, right? And so you can say, I want 3 replicas of my data, but I don't want any more than 2 copies of the same row, or whatever. You can kind of make up your own rules on how the data needs to be distributed, and Crush will then handle where all that replication goes. So the way that it gets there is you have some object that you're going to start in your cluster, and it splits it out into a number of logical groups. We call them placement groups. This is one of the tunables in Ceph. It's a 4 meg chunk of your data, and splits it out, which is configurable. You can change that. So it takes the object name and the number of placement groups, and it splits it out. And then it's going to take those placement groups, and it's going to write it based on the calculation, that Crush calculation. It's going to write it to an OSD. That OSD, in turn, is going to, based on the replication rules, spit it out to the secondary or tertiary OSDs, or how many ever replicas that you decided to do. And it's going to do this a whole bunch of times, and it's going to push it in. You're going to see you have kind of this pseudo-random placement where no 2 of the same placement groups are shared across an OSD. So the advantage here, obviously, is the client can then go in, it'll do its Crush calculation, and it'll know exactly where to go. So the monitor you're noticing is not in the data path, which is great because this removes, again, one of the tenements when we were designing Ceph was no single point of failure. It's kind of become a mantra. And so not having a single point of failure and being able to go direct to where your data is provides a lot of really great performance results. So what happens when we lose one? We blow it up, half your data center burns down, somebody trips over a power cord, whatever it is, we lost an OSD. And so the other 2 OSDs know, hey, I have a copy of this data that's no longer meeting the replication rules that we've set forth. And so we know now that we need, based on this new cluster, we know where the data needs to move to, so that when a client makes their calculation on where things are supposed to live, it goes to the right place. And so they automatically peer with the OSDs, reshuffles the data, and you'll notice that it's only moving the data that it has to. It doesn't rebalance everything. So if you lose an OSD, you're not seeing terabytes and terabytes of data getting shuffled around all the time. So now the client can do his calculation and find the data where it needs to be. So that's kind of Ceph, the guts, how the basics of how it works. So we'll talk a little bit about Ceph and OpenStack. Like I said, OpenStack is a bit of a gateway drug. People will come to the block and then they'll realize that, hey, there's all this other stuff. And one of the anecdotes that I like to share is I'm kind of new to the storage world, the raw storage world. And so I was rather surprised when people started telling me, DBAs and whatnot, would say, for every n terabytes, that equals a storage admin. And as we get big, we have to hire lots of people to do this. And so it didn't quite hit me as hard until I started talking to those people how much Ceph was kind of alleviating that pain. To give you the example is DreamObjects, which is one of the earliest production deployments of Ceph. DreamObjects started at 3 petabytes. And now there's a Dream Compute service, which is 5 petabytes. So 3 petabyte cluster, 5 petabyte cluster are both run part-time by one guy. And so I don't know if any of you are DBAs, but that just tends to floor some of the folks that are part of some of the old guard. Which is really cool because Ceph does all of this self-healing and the replication and kind of offloads a lot of things that used to be manual tasks and makes the cluster a lot easier to manage. So, in addition to being able to run on commodity hardware and save you a lot of money there, it saves the guy time and hassle, and that's rather nice. The other thing is, with Ceph, and I can probably dig into this a little deeper in a minute, with Ceph, there are a lot of really cool parts about it being on an object storage backend, especially like the block device. it starts to even out some of these hotspots, right? A big part of a DBA's life used to be, okay, I need to worry about balancing, I need to worry about traffic, I need to worry about kind of just the general heat and state of my cluster. Ceph's basic design tends to remove a lot of those things. So I'll get into that in a minute. Some of the other stuff that goes along with OpenStack that's pretty exciting. You've got your Keystone identity now, and there's even some CEPH stuff that people are starting to work in. As CEPH matures, some of our early adopters are really taking advantage of it so that all three services, Object, Block, and File now, are becoming part of the OpenStack movement. One great example was with an OpenStack deployment, you have some number of hypervisor machines. And as you're spinning up your virtual machines, it has to go to Glance, get the image, bring it out, spin up a machine, unless you're doing Cinder cloning or whatnot. And one particular install I noticed, instead of waiting for that copy from Glance, from the image store, they're using CEPH with Glance. So now when I take an image, I take this golden image and I push it into Glance. It immediately puts it into CEPH and replicates it so that is then mounted on all of the hypervisor machines. So now there's no copy, now it's local. Now it just instantly starts booting out. So there's a lot of cool things that you get with kind of all of this all-in-one story. And I expect that as CEPH matures further, that will become even more apparent. So, the block device. This is where most people come in. So the first thing about blocks. As I was mentioning, you get a lot of really cool things for free. So the fact that you have a block device and it's striped over many objects, which means it's striped over many logical, physical hosts, means that your block device can now be arbitrarily large or arbitrarily busy. And it doesn't matter, because you're speaking with many hosts and you are allowed to parallelize a large amount of that workload. And so as fast as your network can spit it out at you, you can grab it. So this tends to even out workloads and make you care a little bit less about the constraints of the block device. We also get some cool things with the block device, like instant clones. So I'm not sure who's familiar with the idea of copy and write cloning, but it's the idea of having a golden image. And I want to spin up 1,000 machines. Historically, that would mean, okay, time to copy this image 1,000 times, and then I can start moving it up. With the copy and write cloning, now you have the ability to take this golden image and say, I want 1,000 copies, and it immediately starts booting all 1,000 copies off the single image. So now as they boot up, you'll have people that'll start writing to them. So there's a lot of really cool things that we get for free. So, the object interface. As I mentioned, we speak both Swift and S3. This is the part that's most tightly integrated with Keystone. So this is what you would see with like the Amazon S3, right? So you can do a lot of really cool things like DreamHost actually enabled it so that you could host an entire website on S3. So you push all your website into Dream Objects and you just run it off of Dream Objects. So you don't have to worry about anything else. It does all of it for you. But the nice part about this is me. I came from a background of web development. I spent my first 10 years of open source life cutting my teeth on Slashdot. And so Slashdot had, in its heyday, amazing amounts of traffic. And so we would spend most of our time worrying about how to balance and handle the traffic that was coming into the website. With this, with your objects, your object interface, whatever you're serving from your object interface, you can spin up an arbitrary number of Rados gateways. Completely horizontally scalable. You throw an HA proxy box in front of it, boom, you're now ready to go. You can also do round robin or any kind of load balancing that you want to do in front of it. But it becomes very, very easy to kind of handle this load because it's all based on the storage backend, which you can scale out or down as you need it. So, a lot of cool stuff from the object interface. And then the file system. The file system, the only thing I really wanted to point out, while it still is, I guess it's not early days, but the part about the file system is the file system introduces a new type. Remember we talked about the OSDs, and we talked about the monitors. With the file system, it introduces a third type. This is the metadata server. And the cool part about CEPH is the metadata server, which was designed to be that scalable thing, right? So the history is you would have metadata, and that tended to be one of the bottlenecks as you have to keep track of the directory structure and all the metadata around what was going on with your file system. CEPH has a horizontally scalable metadata server. So what this means is, and it's not static, so you don't have to spend a whole lot of time working with it. So what this means is that you would have some directory tree, and as that directory tree gets busy or large or whatever, as the load changes on this directory tree, the metadata servers will dynamically allocate who handles what part of the tree. So this means that you're always shuffling kind of the metadata, but again, if you see here, the only thing that it gets from the metadata server is that metadata. For the data itself, you're still going directly to the OSD. So this allows you, again, to kind of parallelize that workload and get a lot of great things for you. So that's kind of CEPH. Don't want to spend a whole lot of time on it because, again, it's still pretty early days. Oh yes, the Linux distros. So we have a pretty good footprint. We started on Ubuntu. This is where we kind of live and breathe every day. This is where we did our original development. So obviously the natural extension was Debian. But since then, we've expanded into all these others and several others that are pending. We're in Apple. We're going to be in the next version of RHEL, I believe. And then, Cent, OpenSUSE, and now there's some Slash stuff coming as well. So, all kinds of support. We have build and test infrastructure that we built ourselves. Because it turns out, when you try to test a distributed environment such as ours, there really wasn't anything that was out there that was great that could do it. At least not like we needed it to. So we built a tool called Ecology. And it's actually, now we're making it more and more publicly available. So it's all open source. If you want to stand up to Ecology and use it as a build and test infrastructure for your CEPH, you're welcome to do so, and we'd be happy to help. So what's next? Where are we headed? Havana? Okay, so the next part of the next release of OpenStack has been a lot of work on RBD. One of our developers, Josh Durkin, has been putting a lot of commits back into OpenStack, as well as our Greenhost friends. So people with intimate CEPH knowledge have been spending a lot of time making sure that OpenStack really is tightly integrated with CEPH. So a lot of our work in Havana is all about RBD. So better boot support from Nova. We're also doing the incremental backup stuff in RBD and allowing that to be managed by OpenStack. So a lot of really cool stuff that's coming, bells and whistles, down the line. And then we have some plans for Icehouse. The live migration stuff, we want to do a little bit of improvement there. There's some bug fisting. But mostly the important part here is obviously, as more and more people adopt OpenStack, and as more and more people adopt CEPH, there are going to be possibly changing needs, additional needs, or just tweaking the existing things that are there. And that is a huge part of what I like to do. I like to go out and talk to people and say, how are you using it? What could be better? And CEPH has a very open development process. Every 3 months we get together, we call it our CEPH Developer Summit. It's a virtual summit, it's online, anybody can tune in and see what's going on. Developers, whether they be from Tank or anywhere else, will submit blueprints. They'll say, hey, here's a feature I'd like to see, or here's a change I'd like to see. Most of them are saying, I want to lead this development effort, I would like some feedback. But a fair number of them just show up and say, I want this feature, I can get you 10% of this feature. And maybe 3 or 4 other people raise their hands and say, yeah, I'd like to see that happen. And so we all get on a conference, it's 2 half days. So we all get together on a video conference and we talk about it, and Sage gives some feedback and we decide how we're going to get there. And then we kind of build out a roadmap and say, all right, here's what the next release is going to have and here's how we're going to do it. So that's the biggest part, is anyone, technical or not, can help drive the roadmap on both CEPH and OpenStack. But obviously we're definitely interested in hearing from folks. So the Ceph training, where are we headed next? A lot of work has gone into geo-replication. So the first pass at this came out in the last stable release. This was the stuff with the DR stuff that I was talking about. So the ability for your block devices to take incremental snapshots and pass it back and forth between clusters. There's more coming. With the next stable release, you're going to see the ability to take your object gateways and actually plug them together across multiple clusters. So you can see kind of that replication. And eventually what we're going to do is that underlying object store, the Rails, we're going to make it so that you can have multiple clusters and replicate them at the very lowest level for everything. So we're kind of taking baby steps to get us there, but eventually we're going to have the full geo-replication. But even right now, your S3 gateways, you can treat them just like S3 does. You spin up a bucket in US East or US West or EMEA 1 or whatever it is. So we're definitely moving very quickly there, and I'm really happy to see some of the geo-replication stuff. The next big piece is erasure coding. Not sure who might be familiar with erasure coding. Erasure coding is basically how can we get more bang for our buck out of our storage again. And we're actually putting this together with tiering. So we're headed towards dynamic tiering. So remember, we have the ability for a crush map to define what's going on in our data center. We can even further say there's a pool we call pool fast. And that's all flash or SSDs or whatever, fast storage, the expensive stuff. We can have some other pool that's normal and some pool that's cold storage. The idea is tiering is based on the heat of this data, how often it's accessed, how many people want to get at it. It'll be able to move between those pools. So you can actually, if there's a whole lot of requests on something, you can bump it up to your hot storage. Or if it hasn't been touched in 6 months, you drop it down to cold storage. And with cold storage, maybe that's erasure coding. The thing with erasure coding is it's harder to update and it's harder to recover from, or it just takes longer to do those things. But it needs fewer replicas, which means it takes up less space. So, all kinds of tricks. And then on top of that, we're doing some governance work. I already talked about how we have a very open development process. We're working on making it open-er. So we want to talk about, we've been talking a lot about how do we get what we do out in the public? How do we show everyone what's under the covers? So that no matter what you want to do, you know exactly how it's going to work and how you can get from A to B. So that's kind of what's coming. I buzzed through that pretty fast. Do we have any comments, questions, anything? I'm happy to answer any questions that are separate. Although not in Dutch, unfortunately.
Question?
Yes?
What's the amount of overhead in an hypervisor combined with storage for the crush calculations?
Yeah.
Which intensive? Do you recommend reserving it for, or?
Yeah. It's really hard to say. I've seen widely different results depending on the workloads. There are a number of people, I will say, that are co-locating their hypervisors and Ceph nodes. Mostly, we tend to like to recommend people to separate them, simply because we can't control what goes on in the hypervisor, and the hypervisor is prone to massive resource spikes. And that could then have an effect on your entire cluster, because the cluster is very chatty. So a typical setup with a Ceph cluster with an OSD is you're going to have a client-side network and you're going to have a cluster-side network, right? As multiple. And with a hypervisor machine, now you're no longer constrained by network. Now the resources in the box are actually going to slow it down, and that's going to have implications for the rest of your cluster. So the fact that we aren't in control of the hypervisor is why we generally recommend you not. But that said, with Ceph, it's not. The individual OSDs themselves aren't terribly resource intensive. So you could be very well. Question? No? All right.
What's your business model?
A business model. Oh yeah, I forgot. It's the ink tank stuff. Nigel will be so terribly mad with it. So it's much closer to like a Cloudera model. which if you're not familiar with that, cloud era model is subscriptions. Is primarily we get it, but we do training. So we support you getting to where you need to go. So we can do consulting and training, but also the subscription stuff. And one of the things that I mentioned is that a number of monitoring tools are coming down the pipeline. And one of these big efforts at Inktank is the Inktank kind of providing you goodies to go with that subscription. And one of those goodies is it's a all-in-one kind of monitoring and performance and analytics tool for your cluster. And we're internally calling it Calamari. But it's basically going to be the pretty dashboard for your Ceph cluster. So there's a lot more stuff coming down the pipeline, but primarily our business model is the subscription model. Other questions? All right. Oh, yeah.
Okay. You mentioned during your presentation that data was split into chunks of about 4 megs.
Yeah.
And you also mentioned that block devices is one of the key features that Ceph does.
Mm-hmm.
However, most systems that use block devices tend to access fractions of data on it, about 4K each.
Mm-hmm. Yeah. Well, I mean, it'll depend on your workload. So those are two different things, right? So your block device is going to be split across a number of these 4 meg chunks. And so if you access one piece, you would just then access that 4 meg chunk. It's not really going to have an impact on, you don't have to pull down the whole 4 meg chunk. It's just a logical separation to know how to split it between the physical hosts themselves. And that's the object layer. The block layer is one level higher. So the block is going to be split across the objects that you're moving across. Does that make sense?
Yeah.
Okay. Anyone else? All right. Sounds like a whole lot of nothing. Thank you very much, guys.
Thank you.
Now taking a break about 15 minutes, and then we going further with the next 2 speakers. So about 3 o'clock we start again.